In this video, we are going to discuss about ideal transform. What is ideal transformer means? You should have a perfect coupling. That is, the coefficient of coupling must be equal to 0. So, if it consists of two or more coil, which is having a large number of turns, which is wounded on a common core, which should have a high permeability. Okay. So, first condition is it should be perfectly coupled, and next condition is you should have high permeability. So, because of this high permeability of the core, the flux will get links on the all the turns of the both coil. So, which will result in the perfect coupling. Okay. So, let me draw the. So, this is your primary side, and this one is your secondary side. Okay. And this one is V1, and the current flowing through this one is I1, and this one is I2. Okay, and this is V. Okay, so N1, N2 represent number of turns. Okay, so I can write what is V1. V1 is equal to J omega L1 into I1 plus J omega M into I2, right? So this is your first equation. So since here also current is entering, and here also current is entering, so I can write V1 is equal to plus J omega M into I2. Okay. So similar way I can write V2 is equal to J omega L2 I2 plus J omega M into I1. So this is your second equation. Okay, so from this I can write what is I1. From first equation I can write I1 is equal to minus J omega M I2, okay, plus V1 divided by J omega L1. Okay, so you substitute this this third equation in the second equation. So what is V2? V2 is equal to J omega L2 I2 plus J omega, and take this out. J omega M instead of I1 you substitute V1 minus J omega M I2 divided by J omega L1. Okay. So we know that for perfectly coupling M is equal to K into root of L1 and L2. So K value is 1. So what is M? M is equal to root of L1 L2. So J omega L2 I2, okay, plus J omega get cancelled out. So I can write root of L1 L2 instead of M. So you cancel these two, you will get L1 V1 minus J omega root of L1 L2 into I2. Okay, so this is equal to J omega L2 I2 plus root of L2 by L1 V1 minus J omega So root of L1 L2 into root of L1 L2 is L1 L2 I2 divided by L1. Okay. So this L1 and L1 get cancelled. Okay. So if you see, these two terms get cancelled out, right? These two terms get cancelled out. So I can write V2 is equal to root of L2 by L1 into V1. Okay. So what does my root of L2 by L1 value is? Nothing but M. Okay. Where N represent turns ratio. That is equal to root of L2 by F1. So if as L2 and L1, L2 and M reaches infinity, okay, N remains same, right? Because this 2 get cancelled out and it will remain the same value. Therefore, the properties of ideal transformer is the first one is K is equal to 1, which we have already seen, and the coil is having very large reactance. So what it means, L1, L2 and M reaches infinity, which means is a very, very big value, right? So next one is you should not have any losses. Therefore, the primary and secondary coils are lossless. That is R1, R2 is equal to 0. Okay. So I can define an ideal transformer as a unity coupled lossless transformer. Okay. So what is ideal transformer? Is a unity coupled. There is K values 1, right? So unity coupled lossless transformer. So in which the primary and secondary coils have infinite self-inductance, right? That is L1, L2 is goes to infinity. So it is used in power electronics. So the application of this one is it is used in power electronics, and it is used also power electronics and power systems. Okay. So previously we know that V1 is equal to N1 d phi by dt, right? And V2 is equal to N2 d phi by dt. So therefore I can write V1 by V2 is equal to N1 by N2. Okay. So what is V2 by V1? V2 by V1 is equal to N2 by N1. So here N by 1. So this primary values, so this N represent it is a turns ratio or transformation ratio. Okay. Ratio. And according to the law of conservation of energy, I can write V1 I1 is equal to the power consumed by V1 I1 is equal to V2 I2. Okay, so I can write V2 by V1 is equal to I1 by I2. So that is equal to N2 by N1. That is equal to N by 1. Okay, so I can write I1 by I2 is equal to N by 1. That is N. Okay. So if N value is 1, okay. So if N value is 1, we call this one as an isolation transform. Isolation transform. Okay. So if N value is greater than 1. So if N value is greater than 1 means V2 is greater than 1. So V2 is greater than 1 means it is step up, right? So it is called as step up transform. In similar case, if N is less than 1 means it is called as step down transform. Okay. So another important condition is so consider if we have two coils, this is a primary and secondary coil. Okay. So this is your V1 and this is your V2. Okay. So if this is the case, I can write V2 by V1 is equal to N2 by N1. This is the first case. Okay. The second case is, if this is a case, I can write V2 by V1 is equal to minus N2 by N1. Okay. Next condition is the first current is I1 and this is I2. Okay. So here you can see one current is entering and another current is leaving. Okay. So if that is the case, I can write I1 by I2. I1 by I2 is equal to N2 by N. Okay, the next case is if both the current are entering, then I can write I1 by I2 is equal to minus N2 by N. So these are the four cases.